Okay, in this video, we're going to take a look at some control statements, so if else's, some for loops, just to kind of cover those and make sure we really understand what they are and how they work. We've seen them a bit so far, but this will just kind of give us a quick overview and a good understanding of all of the potential use cases. So let's start off with a simple if statement. So I'm just going to create a variable a, which is going to be an integer. So as we've seen before, we can do if a equals 1, then we can just print out some text here. So let's do a equals 1. And if we run that, we can see, that we do get the output as we expect. We've seen this as well. You can do an else statement. So you can do print in the else. And then if we just change a to equal 2, we see we go into the else statement. Another thing you can do is you can do an else if. So you can do else if a equals 2. Then we'll just print out a equals 2. We'll just print out a equals 2. So just clear this. Ooh. And we'll see that we get a equals 2. So that's a simple if, else if, and else statement. One thing we've seen as well before that's quite a common pattern is you can do essentially a statement can precede your conditional. So we've seen this before with the error statement. So you can do error equals like some function. And then you can do if error does not equal nil, do something here basically. You can do that with basically any kind of statement. So it's not just the error statement that you can do this with. You can do, for example, num equals 1. And then like if num is less than 0, let's print out our number. So less than 0. We can then of course do an else. Let's just do an else statement here. And we'll just print out the number and greater than 0. So of course, if we run this, oh, a is not declared, get rid of that. On this, you get 1 is greater spelled incorrectly. And if we change this to be -1, we will see we go into the first block as well. So again, that's just one of the things you can do there with the if statements. You can have a logical block. So you have your statement essentially, and then you have your conditional, and then it jumps into the block that meets that condition. And as we saw, the pattern often is you do error something, and then if error does not equal nil, you jump into this block here. Otherwise, you jump into the else block. So again, the pattern you'll see a lot in Go code. Okay, now let's take a look at some loops in Go. Now there's only one kind of loop in Go, and that's a for loop, which we have seen before, but we'll just run through it again. So let's just create a variable of I, and then we'll do the most basic loop. So I is less than or equal to 3. We'll just then print out I, and then we'll have a condition to increment I. So we'll just add 1 to I there. If we run that, we will see that we get an output of 1, 2, 3, as we would expect. The other way to do this is kind of the classical initialization of your variable, the condition, and then the actual increment of the loop. And we've seen this before as well. So let's do that again. So I is 0. Let's go for 0, for example. We are then going to do the condition of I is less than 3. We're then going to increment I within the initialization of the loop. This is probably the most common loop that you will see. So if we run this, again, we get 0, 1, 2, as we would expect. Another thing you can do in loops is using the range keyword. So if we do I equals range and then a number in this case, and we can just print out that particular I, and we'll see that we just get 0, 1, 2, as you would expect. The other thing you can do with the range keyword is you can actually range over maps, slices, and arrays. Let's just go ahead and create a simple slice. We'll just create a slice of strings and we'll give it a length of 5. There's nothing actually in this slice, but that doesn't really matter for our example. So we will do our particular slice here, and we'll just iterate through that, and we'll see we get the index of the slice. And if you had anything in that particular slice, you would access it via the index like that. The other way you can do this is you can use two variables, so where I is the index and V is the value, or it doesn't have to be V, it can be anything in particular you want. And again, nothing actually in this slice, but you'll kind of see the example and see how it works, as expected. One thing to note, in this particular case, we are actually creating a copy of the value. So it's a copy of the value at the index in that particular slice. Whereas when you just do it over the range like that, it's not going to be a copy. So when you access your slice via SI, that's a reference to that particular value. Now, generally, this is not a big issue, but one thing to be aware of, obviously, is if your slice has items that are particularly large and you use this syntax, it will be copying it over every time. And obviously, the larger that value is, the more memory it's going to take. So just one thing to be aware of. As I said, we can also iterate over maps as well. So let's just make a map of a string to an integer. So that will work as expected. Again, the map is empty itself, so we actually get nothing in there. Obviously, because the map is empty, there's no iteration that occurs there. But it's good to know that you can do that. Again, as you should know, maps in Go are unordered, so you can't guarantee the order that it will loop through in a map. While loop, although they don't actually exist in Go, you can create it with a for loop, like so. We create our essentially infinite loop at this point. We then need to have a condition that will break out of the loop. So if we do like if I is greater than 3, for example, we're going to use the break keyword. Above this, let's go ahead and print out I, and then we will increment I below here. So if we run this particular code, we should see that we get 3 and 4. I'll just make that 1 for clarity, maybe make it slightly more easier to understand. So yeah, 1, 2, 3, 4, as we would expect, and obviously it catches into this block here at 4 and breaks out of the loop. So the final thing I just want to cover with loops is quite a useful thing. It's labels for loops. So for the example here, I've just got two slices of strings. In this case, I've got keys and I've got values. And this is quite a common thing that you'll see in various programs, is when you want to do basically a nested loop. So we're going to loop through the keys to start off with. We're using this placeholder value, the underscore here, which is just basically ignore this value. We're not actually going to be using it. So we're going to loop through our range of keys and we're going to get the value of that key. We're then going to loop through our slice of values themselves, grab the value from that. We're going to compare the value in the keys to the value in the actual values list. If they match, we're then going to do what's known as continue and then pass in the label of the outer loop. Otherwise, we'll just continue with the loop. And what this basically means is that when we check whether A is in our values slice, we'll first check A against E, they won't equal, so the loop will continue. We'll then check A against A, they will equal the same, they are the same thing. So we will come into this continue loop here, and then we will basically continue on the next level of the keys list, keys slice. And that means basically we never need to continue looking in the inner slice because we've already found it and we can just continue the outer slice. Let's just run this code and we'll give that as an example. So as we can see, A and E are not a match. So we come into this else block here. A and A are a match. So we are continuing our outer loop. And you can see here, we don't end up with A and F because we've continued and we're on to the B key. You then see we get B, E, BA, and BF, none of which are a match. So that's just a useful thing to know if you ever have nested loops and you basically want to break out of the inner loop when you find or meet a certain condition. You can use labels, so outer loop in this case, and then you can continue that particular loop. Just a good thing to know. Final thing I want to cover in this video are switch statements. So switch statements are basically just a nice way to write lots of if-else statements. So if we create a switch statement here, so the keyword switch, you then have what you're switching on. So in this case, we're going to switch on the I variable, and then we'll just do case if I equals 1. Let's print out that I equals 1. We'll then have another case of case 2, and we'll print out that I equals 2. We then have another case if we want. So let's do case 3, and we'll print out 3. So with a switch, it's just switch, then your condition, and then your cases. And this is basically, if A, else B, else C. It's just a nice way of writing all of that because that's a bit of a pain to write. So if we run this switch statement here, we will see that we get I equals 2 because that's what we set it to. There is also the default keyword here that you can use, and this is basically what will fall through if none of your conditions are actually met. So let's do this. So default, we'll then set I to be 4. So we don't have a case for 4, so it should run into our default, and we see that it does. Another thing you can do with cases is you can have multiple conditions on the same line. So we could do 1, 2, 3 like this. If we just get rid of these now, and we'll just do in our case. So change that to be 2, and we will see that that works as expected. Another thing you can do with switch statements is you can actually have a blank switch here, and then you can have your logic in the actual case statement rather than doing it on the actual input item. So here, if we do I is less than 3, for example, we can then change this to be I is less than 3. If we run this, we will see that we get I is less than 3. We can go ahead and create a new case here. That will be I equals 4. Let's change I to be 4, and we'll see that it jumps into that particular, I didn't change it, I equals 4, and we'll see that we jump into that particular statement there. So you can do the conditional logic within the case statement itself. One thing to note about switch statements that are different from some languages is it breaks by default, so you don't need to add the break keyword here. I know in some languages you do need to add break to break out of that particular case. In Go, you don't. As soon as you hit this case, it will break out of the switch statement. And it's important to know that it evaluates it from top to bottom. So basically, it will evaluate this case first, then this case, and then ultimately the default will always be the last case that is evaluated. And that's basically if statements, for loops, switch statements. Not too much to them. They are fairly simple, but it's good to know what you can do with them. And in the next video, we're going to run into packages and look a bit more into the way that packages work in Go.